Technology. It drives us forward, implores us to innovate and to challenge the status quo, paired with an opportunity like no other.
Sports can play a role by becoming this platform where the best technology wins.
We're not going to the grocery store with these machines. We're jumping them and pushing them to the limit.
A championship which provides a test bed for what is possible.
The level's so high and we have to push probably harder than we're supposed to.
We take it to the next level.
Let's try to do something different.
A racing series with a mission that goes far beyond the track.
We're not only here racing, but we're also driving change.
Technology is absolutely essential to fighting the climate crisis.
To find solutions to the biggest problems facing our planet.
It's all about developing and making something better.
If we can do it here in the middle of nowhere or the middle of the ice shelf in Greenland, we can do it anywhere.
I still can't understand how insane this is.
This is Extreme E.
Prepare to be aggressive.
Hyperdrive now.
Conceived as the world's first off-road electric racing series, the task of developing the Odyssey S01 was no easy feat. The championship had one mission: make a racing car able to withstand the world's harshest conditions and most extreme terrains.
I'm a huge believer that motorsport has changed our lives in the last 100 years. Like seatbelts and disc brakes and all the things we have in our cars came from racing. So we need competition to really push the envelope of innovation. Doing this in an EV world is a new thing. Even though everybody has the same battery, we're not going to the grocery store with these machines. We're jumping them and pushing them to the limit in some of the worst, gnarliest environments on our planet.
Before Extreme E, no one had done an electric SUV that should drive in these extreme conditions. It was always going to be a bit of a journey. Us drivers haven't made it easier for them either. The level's so high and we have to push probably harder than we're supposed to. Then, you know, they have to make their car stronger, and now it's a solid race car.
We selected Spark as our Extreme E race car designer because of their heritage and experience in Formula E, dealing with high voltage battery EV race cars. Their ability to transition from a circuit race to an off-road racing car was incredible. They rose to that challenge and they've adapted and brought all of that learning from dealing with high voltage race cars.
Between the very first prototype, let's say, or even season 1 and nowadays, we have worked on many areas of the car. We have reinforced some mechanical components. We have improved, for example, the cooling of the battery to be able to have more races in one day. So my first idea was to use air cooling. At that time, the race format wasn't completely defined yet. It was meant to be more time between the outings, between the heats. It was fitting to the original plan. And then quickly the series starts. We saw that everything was becoming live on TV, so the timing between the outing was really, really short. After 2 races, I would clearly realize that we had to do something. The cooling system we developed on the battery is based on a system which has been developed for satellite. It's a tube, and inside the tube you have a liquid that can evaporate at low temperature. And when it evaporates, it becomes vapor. The vapor goes up, and then when we come to the top of this tube, it touches a plate that we cool down, it condensates, and then it becomes liquid again, and by gravity, it runs down back to the hot spot and evaporates again, and the cycle is automatic and without any outside energy. If it would have not been Extreme E, maybe people would have said to me, don't worry Fred, we can use something that we normally use. But here, thanks to being away from everything, it gave me enough reason to say, let's try to do something different.
Right out of the gate, we went straight into Sardinia in season 2, which is a pretty challenging race for dampers. The terrain is pretty unforgiving. There's some big holes and jumps and things like that. And it was a double header. So we got data from the teams really quickly on what the dampers were doing. And with that data, we actually decided to make a couple design changes. But since then, they've been relatively unchanged. I think they've proven themselves, and I think the other evolution from season 2 to season 3 is more on the team side. The teams figured out how to set them up and tailor them to their drivers. You can see that in the way the cars are handling and the way the racing is getting faster and the battles are getting better.
Off the track too, Extreme E endeavoured to push the envelope of what was possible when it came to technological innovation. Televised live from locations such as Greenland's ice sheet and Chile's Atacama Desert, the broadcast of the championship has redefined the landscape of TV production.
Remote production isn't so much new, but we take it to the next level. Working in very remote locations creates huge challenges, and with challenges comes innovation.
So the brief from Extreme E on paper when they first came to Aurora was to be able to take this kit and be able to take it anywhere in the world, and to be able to deliver a live programme from those locations as the action happens with the minimal delay possible.
We've kind of pushed the boundaries technically on this project in every sense. The biggest challenge was actually the remote connectivity to the location facilities, which could be anywhere on the planet. So the team put together a satellite solution, which meant we could operate practically anywhere in the world.
So if you think of it as like a big orchestra, and me and the director who sits beside of me, we have the responsibility of making sure the violins are playing this, the trumpets are playing that, to deliver the song at the back end. And we do that in conjunction with another director, another producer back in London. The footprint of the circuit is about 3.7K. We have 6 line cameras around that, 12 remote cameras, 2 handheld cameras. Every car has 3 onboards on. We have special cameras in the command centre. We also have 2 live drones. One's an FPV drone, one's a master overview drone, and all of that feeds back into here. We take all of our camera lines and they are beamed back over 2 satellite paths to London with redundancy. London then is the hub of the whole operation. They put the commentary on, they super serve the graphics, they encompass the VTs, the replays, the EVS, the timing systems, etc.
One of the main parts of this production, which is quite new, is the marriage of sporting graphics, AR graphics and virtual graphics. Pulling those all together is a challenge in itself, but what we also have to do is they're all remote. So we have our gallery here in London, which is putting a final show together, but we're taking the live pictures from on site. Our sporting graphics are coming from Alcanelli. Our virtual graphics are coming from Holland. Our job is to literally pull those bits of string together. So this workflow relies on actually getting live footage instantly from on-site. So a race cut is being produced on site, we get the camera from on site, just I think with maybe 4 or 5 frames delay even here in Hilversum. And then our operator gets it on screen and he applies the graphic, it goes back and then it's all within a second. If you still ask me, I still can't understand how insane this is and how marvelous. Because I mean, if you want to get to Chile right now, you need to get in a plane, you need to take the bus, the car, whatever, it takes you a full day. But right now we're just getting feed on site, we apply graphics and all within a second it gets back to the program. So besides having the speed of the car and the positioning on the track, we actually get live GPS data, and this live GPS data we use in our virtual map to also locate where they are.
We look to minimize our footprint and we look to use innovation to change and to challenge the status quo within these industries and ultimately become far more efficient in terms of what we're doing, but also much, much better.
The media industry has a responsibility, like every industry, to look at its carbon output. Sport happens globally around the world. Traditionally, it's taken a lot of people to produce that on site. And this project has been a leader in reducing the amount of people who travel, the amount of time people spend on it, because we're reducing the travel days, because you can do it locally in London or Holland. And equally, everything we see here in this broadcast facility is 100% sustainable. So it's powered by hydrogen or solar power. So we're Albert affiliated and we're a carbon neutral production.
We look forward to leading the way as we've been doing with this production. If we can do it here in the middle of nowhere or the middle of the ice shelf in Greenland, we can do it anywhere.
Earlier this year, as part of the championship's legacy programme in Scotland, the Extreme E drivers helped install Vodafone sensors to help measure water temperature and quality. A few weeks ago, Vodafone Business paid a visit back to the site to see how this technology was working and how it could be utilised to better understand the climate crisis.
Salmon have been declared in Scotland as being in crisis. Numbers are depleted from that as they used to be. Extreme E were very keen to support any initiative that we could to reduce that climate change impact that we're having on Atlantic salmon. Sent their drivers along, planted a few trees. I met Vodafone business there, and they were very keen to support and help with the fight against climate change and increasing temperatures in those water courses.
So Jim, great to see you again. 6 months in since we met in May. How's the project been going?
Good, I'm really excited about some of the results we're starting to get there.
Anything interesting you've seen already?
We always knew that it was going to be cooler, funnily enough, in the shade, but I didn't appreciate how much cooler it was going to be. Tree-lined riverbanks means cool, clean water. It's got to be good for the fish. I really think the damage is done in the open areas. Shallow water heats up very much quicker, more detrimental to fish.
So that validates your plan, your idea to introduce more shaded areas around the river to cool it down?
Correct, and to use the sensors to prioritise our efforts.
So the water quality, Bob, we noticed that actually the pace of the river was overwhelming the flotation system. So the lab, they've redeveloped the main flotation buoy to make sure we're more resilient.
Yeah, I like go green.
Yeah. Oh, yes, that's looking a lot better, isn't it?
That's really pretty good, isn't it?
It's very important that we've got the new piece of equipment because that monitors the relative difference between the upstream sensor and the downstream one, so we know what the impact is between the two. The Vodafone sensors are giving me a wider coverage than I could ever hope to achieve if I was driving around the catchment and sticking a thermometer into the river. This is giving me instant data right across the catchment. I want to see the river full of salmon because salmon's important to this area. People have always fished for salmon here, and all the rural businesses that rely on people coming to stay here. This is the time of year when the rural economy really needs that boost.
So technology can provide an answer, or part of the answer. We start with a sensor, but we've got to turn that sensor data into something meaningful. And if we can turn that information to be useful to the River Nith, to help them make active change faster around the river environment for the Atlantic salmon, then we've done a good thing, and that's made an impact. We're really hoping that we can apply the same technologies to other environments, particularly remote environments, possibly in glacier applications, but ultimately we could be building a solution here for scientists to monitor temperature in almost any scenario, be it hot or cold, damp or dry. And I think that'll be really important going forward to see how we contribute to a greater scientific pool of data.
A championship driven by the climate, Extreme E enlisted the St. Helena to become the championship's floating paddock, shipping the cars to each location as an alternative to flying. A prerequisite for this, though, was to be able to track and offset the emissions of the ship. Partnering with Alcott, the championship are implementing this through groundbreaking new technology.
My visit on the boat today is really to be able to capture what the Santa Helena footprint is. Today I met with Spencer, who walked me through all the different steps that they are actually using at the moment to collect this information about the consumption of the boat. So we've been through the bridge, the deck, the engine room, and finding out how daily they are collecting this information. What we're looking for is really to gather all this information and unify it into a collective database and calculate a footprint from that. From this footprint, we're going to use a blockchain system to offset the carbon footprint of the boat on a daily manner. The carbon footprint of the race is very minimal. The hydrogen charging is very efficient, but one of the key factors that Extreme E has been using is this ship, which is actually in itself an environmental positive action, because instead of using a brand new ship, they actually took a ship that was designed to go to the scrapyard. The Santa Helena is not yet an electric boat or an hydrogen-powered boat, so at the moment we have to maximize on the chances that we can get to make it environmentally positive.
Raphael, welcome to Extreme E headquarters here in West London. I'm really excited to see the real-time data.
Yeah.
So let's get started and let's see what we've achieved together.
We receive now from the boat every day the log about the amount of distance they traveled and also the consumption in cubic meters. On this journey, on 31st of October, it consumed like 18.2 cubic meter of fuel, which amounts to 56 tons and 540
of
kilos.
carbon.
And I invite you to press on offset. And so like now, the computer actually goes on the blockchain to execute the order of retirement. And now it's been successfully completed. Now it's like part of like the graph, so can help you to see that maybe due to some like weather, we have a slight increase from yesterday. Weather condition, for instance, seems to have obviously like an impact. The boat will need to deploy like more energy to travel.
What this allows us to do is to be responsible and also have that understanding of what our carbon footprint is. And most importantly, how do we deal with that carbon footprint in a daily basis so that the projects get the benefits that day, so that the transfer of funds goes that day. And I think that's about being a responsible business in the future, and that's where we want to lead the sort of industry, not only the sports industry, but the wider society.
During race weekend, whilst all eyes are focused on the competitive action out on track, a team of stewards are monitoring every turn of the wheel, speed infringement and incident. Crucial to ensuring all rules are followed is the technology deployed by the team that can measure even the tightest of margins.
The function of race control over a race weekend is it controls all the racing. From the time the cars leave scrutineering tents and their garages and go to the start line, from the time they finish the race, the entire process is all managed from race control. Technology is very important in what we do in race control. If we don't have data fed back from the track, from cameras, from CCTV, from telemetry, we don't understand what's going on out there. We can't see it, we don't know if people are speeding, and we cannot police the race. To support the work we do in race control, we work with a company called Alcamel Systems. Alcamel are the ones that provide probably the most technology in race control. They will provide all the antennas and services which allows us to get data and telemetry off the car and send it back to race control. If we see that there's been an infringement, or indeed if two cars have contacted or someone's missed a gate, the data will show us that and the race director will be informed. The race director will put on the screen that an incident is under review. It then comes to the back of the room where you have the judge and jury, and that is our stewards. We have a permanent steward who does every race, and we have two stewards locally in the country we're in who support the main steward. They review all the information, they review all the evidence which comes from the speeding, or they review the CCTV or the footage from that, and we have a replay person who can show them in slow motion every single half a metre of the car in action. They can review it and they can make their decision and their judgment based upon all that technology in front of them. The penalties that could be handed out to a team or a driver are defined by exact measurements. Extreme E has had great challenges in making all of this work. If you are at Silverstone or at Monza or a permanent Grand Prix track, you have all the infrastructure around you. We're in the middle of the Atacama Desert. We do not have all of this technology. It's not out there, you don't get 4G. We have a head of broadcast and technology whose job it is to make sure that we have Wi-Fi, we have internet, we have satellite communications, and that we can do the same job as someone can do in a city centre in Formula E or at Silverstone in Formula 1. But we have to do that in such remote places on Earth, and I think we are at the cutting edge of making that happen.
Whilst the stewards are utilising technology to monitor the race action behind the scenes, each team's engineers are using technology and data to ensure the cars and drivers are performing out on track.
So the role of technology is pretty pivotal in this series. In some respects, much like any other race series. Big difference here, though, is that we've got an electric car with the motors, with the way you use the power and you deliver the power. It's so critical because everybody's got the same equipment through the pits. We spend a lot of time optimizing a lot of the systems and how they're used by the drivers in various different configurations on the track, be it a wet track, a dry track, a bumpy track, a smooth track, that kind of thing. If everyone's got the same toys to play with, then it's about finding the little extra bits that others can't. If you look away from the car, we've then got all of the systems behind that. So we get a lot of the data, we can process a lot of the data, We can use it to analyze the driving lines for the drivers, but then also to see that the car's functioning correctly. It's quite important for the drivers to be able to see the data. In terms of them giving us feedback, a lot of what they feedback to us is based on what they feel and what they see when they're driving a lap of the track. There's so many different systems on the car, and especially with the way power is delivered to the front and rear axle, you can have an influence on how the car behaves. So if they come back to us and, for example, say, the car's understeering when I turn in, I need you to make a setup change, it may well be actually that there's an interaction of a system on the car that's forcing the car to understeer. But at least if we've got the data in front of us, we can show them the whole process of from the moment you brake to the moment you turn in, this is what's going on, this is how the motors are reacting, this is where you've got an unloaded tyre because you're cornering, that kind of thing. So it helps them to understand exactly what's dynamically going on and then how that affects them with their feedback. This particular series is different to other series in as much as, okay, we're electric, we charge the cars up, but the way the cars are charged up, the attempt is to do it in the most carbon neutral way possible, and that's why we have a hydrogen station that provides the power that we generate to provide to every single tent, every single car, to every single team. So that as a concept in its own right is very different to any other motorsport. I think it's a step in the right direction.
Made up of 5 of the world's leading climate academics, Extreme E's scientific committee endeavour to help the championship find solutions to the climate crisis. In Sardinia earlier this year, Professor Richard Washington looked at how the St. Helena could be utilised using technology to better understand our weather and climate systems.
We live on a planet which is covered by about 2/3 water. So it turns out we've got very good observations over most land areas, but the oceans, on the other hand, are much harder to recover data for because it's not where we live. So from that perspective, the St. Helena is a great gift to us. She's a floating science platform in my eyes, as well as doing a bunch of other important jobs for Extreme E. And she takes our equipment across oceans through very unusual routes where data, quite frankly, is very sparse. We've got 3 pieces of equipment on St. Helena. One is a LiDAR system, we have an automatic weather station, and we have a motion sensor as well, which tells us how the ship is rocking and rolling in numbers. The LiDAR system shoots a beam upwards in the atmosphere, which is a laser light essentially, every 3 seconds or so, and it can tell us what particles are in the atmosphere, like dust and smoke. And that signal then, if there is stuff in the way, will come back to the box on the ground, and the box on the ground knows how much has come back and how long it's taken. And from that you can recover the height at which the dust particle or smoke particle was. There's another extra add-on to that, and that is if the particle is moving, it'll change the frequency of the light itself. That's something called the Doppler effect. And the clever bit of that is that we can work out the wind speed and the wind direction from that frequency shift in the light. We're interested in dust because it's a big player in the weather and climate system. It interacts with sunlight, it interacts with the cooling system of the Earth and the infrared radiation that the Earth emits all the time. It interacts with weather systems, with cloud droplets, with the chemistry of the oceans as well. So it can provide phytoplankton the food they need, the nutrients they need in order to draw down the carbon out of the atmosphere. So dust is a really intriguing player in the whole conveyor belt of weather and climate. So the next step with the data is to take it back to the lab. We have some preliminary ideas about what the content is going to tell us. But the beautiful thing about the science is that it's almost always true that when you have a new data set, that you uncover something that you didn't expect. And that's one of the reasons I really love science, is the surprise that's lying inside those numbers. And our job is essentially to see what that surprise is. Data for us as climate scientists is extremely important. If we had no data of the planet, then we'd have the suspicion that it was warming and that climate was changing, but we couldn't quantify it. Technology and climate change have an interesting relationship, and let's be frank, if it weren't for technology, then most of the fossil fuels would still be in the ground and we wouldn't have a climate problem. But we're in the midst of a climate problem now, and it's clear that only technology is going to help us recover from the situation that we were in.
But the key to this championship, it's development. No matter if it's working with the car and technical aspects, or working with the tires to make them better, or working with the legacy programs that we do for the environment, it's all about developing and making something better. And that's what Extreme stands for.
We're not only here racing, but we're also driving change and wanting to see the development happening in the tech industry.
I don't think there's any better test bed you can have for something that we use to get from A to B on the street.
It's been great to be part of a championship that's put technology and pushing innovation at the forefront of what we do.